Don't you love it when things freeze and you don't know whether they've frozen or not? Okay, I'm going to try and look at the camera. I'm going to flip it around. I hope you can hear me well enough. I didn't have my mic very well in front of me. I will be working some of the problems on page 307, and you won't see my face the rest of the time, but we will work them. And if you have further questions before you take your test, please ask. All right. But don't wait until Friday to ask those questions. All right. Bye. I mean, not really bye, because I'm still here. That's kind of upside down. Okay. All righty. We're going to start with number 13. Okay. And these are on page 307. Okay. And I'm just going to remind you as I'm working of the things that you already know. All right. So we have 3 times the square root of 32. Okay. Now, one thing that you need to do is you need to ask yourself, is there a perfect square in this number? Like, can I branch it out to be a perfect square times something else? And in this case, hopefully you thought of 16. Okay, and just a reminder, and we're going to go back to the basics on this one. This would be like saying the square root of 16 times the square root of 2 like this. Well, what is the square root of 16? It's 4. So you would actually just multiply 3 times 4 and you would get 12. It would be outside the radical. And what is left? That square root of 2 from up here. Okay, so this is your final answer on that one. Okay, let's try another one. Let's go to number 14. Okay, we're going to work on 7 times the square root of 54. Hopefully, when you see 54, you think of 9 and 6. Okay, if you don't, hopefully when you break it down and you see all the numbers that go into it, I'll do an example over to the side in a second. And you'll know how to work it from then. Okay, so this is, what is the square root of 9? It's 3. So we're going to pull that out. And when you pull 9 out, you're not actually pulling 9 because it's the square root of 9 that you're pulling out. So 7 times 3, 21, and then times 6. And that's your final answer on that. So I'm going to show you off to the side. If, let's say, you looked at 54 and you were like, I don't know, and you saw, well, that's an even number, so I know 2 goes into it, right? So you use your calculator and you find that 2 times 27 gives you 54. And you're like, well, lots of help you are. But hopefully at this point, you would see 3 and 9. And you could pull that 9 out. Okay. If you didn't, well, let's say, well, I don't know how you wouldn't at this point if you're going this way. But if you saw 27 as, this is not normally how we do it, but okay, you had 3, 3, and 3. Well, you're looking for, because this is the square root and there's no number there, we're looking for groups of what? Groups of 2. Now, don't let this get confusing and go, well, there's a 2, there's a 3, and here's a 3. It's either or, okay? It's this 27 divided this way or this 27 divided this way. Don't get them confused and put them together. So you would see a group of 2 right here. You have 2 3s, and then you would pull out that 3 when you are dealing with the 9. Okay. All right. So let's take another one. The next one that I have circled for us to work through is 17. If you want to try and go ahead and pause the video to see if you can rework it first, that might actually be a good thing for you to do to see if you can do it without my help. All right. Okay. So on this, we're looking for, is there a perfect square out of 20? Hopefully you thought of that 4. Okay. So we're going to pull out 2 as our answer. Okay. So we get rid of that 4. And so we're going to pull 2 out right here. Okay. Now let's go back to the a cubed. Okay, also don't forget that 5 is still in there. So a cubed, there's actually, it looks like this, a cubed, right? So we have 2 a's. When we pull out this section right here, we're going to pull out only 1a. So we're going to cross through those. There's not a group of 2 b's, so b would stay as it is. And c squared, it helps to see this, the square root of c squared, which it would be c, and we pull that out. Okay, and then let's see what would be left inside this radical. We have 5, we have a, and we have b because of that and that and that. Okay, so I'm going to rewrite this so it's prettier. 2ac square root of 5ab. This is your final answer. Okay, all right. Next one that I have circled for us to work is a like term problem. It's number 20. And we have 3 square root of 2 plus 3 square root of 18 minus 5 square root of 8. Okay, so this is our problem. We're mainly going to be seeing, you see that too? We're probably going to use it again. Okay, but let's pull out anything that we can reduce. So this is 9 and 2, and this is 4 and 2 are our 8. Okay, so let's see if we can finagle this. And you should see, you see that too? See that too? See that too? Okay, hopefully you saw that it's common. So we have 3 square root of 2 from the first one. Sorry, there it is. And when I pull out the 9, I actually don't pull out a 9, I pull out a 3. So 3 times 3, I still have my square root of 2 on there. And same thing for this. When I pull that out, I do this, 5 times 2 from that 4, square root of 2. So I have 3 square root of 2 plus 9 square root of 2 minus 10 square root of 2. Okay, so now we just look at it like, okay, these are like terms because of all of our square root of 2's. If you want to put a letter in for those, like 3x plus 9x minus 10x, then you can kind of see it together, but we went over that last week, so I'm not going to do that again. 3 plus 9 is 12. 12 minus 10 is 2. Don't forget your square root of 2 on there. Okay, and that's your final answer for that one. Okay, so let's keep working. Okay, we're going to work on number 21. Okay, so our problem right here, we have square root of 12 plus 3 times the square root of 18, which we actually worked with before, and 5 times the square root of 2. So let's simplify first. You should see 4 is here, 9 is in here. Okay, so let's simplify. This would become 2 square root of 3 plus, this would become 9 square root of 2, because don't forget, when we pull the 9 out, it becomes a 3, because the square root of 9 is 3. 3 times 3 is 9 minus 5 square root of 2. Uh-oh, not everything is alike. No worries. We just don't combine what's not alike. So that 2 square root of 3 stays just like that. And then what's 9 minus 5? Well, it is 4 times the square root of 2, and that's your final answer. All right, moving on to number 23. I'm going to give myself a whole page for 23. Okay, sorry. Here's 23. We have, I wanted to do this one because you are going to have to think in terms of distribution. You might not have something exactly like this, but you need to be able to know what you're distributing. Okay. All right, so here's my whole problem. I wrote it out. Okay, and let's start with this. Okay, when I distribute to each one. What is the square root of 2 times the square root of 2? Hopefully you understand by now that pops off the radical, and our answer is just a plain 2. The radical went away. Now, square root of 2 times the square root of 3, and don't forget that negative, so I'm going to put that minus right there. So that would become the square root of 6, okay, because you multiply whatever's underneath. Then here, that 4 is on the outside, and what's on the outside over here? It's a 1 because you don't have anything, okay? So what's the 2 and the 6? Well, that's the square root of 12. But one thing that we did before is the square root of 12 can be reduced, okay? And so the square root of 12 is actually 2 times the square root of 3, okay? Now don't forget, you had 4 on the outside, okay? So that 2 times the 6 was the square root of 12. You get this, but don't forget you have to multiply that by 4. So this is plus 8 times the square root of 3. Okay, then we come over here. We're going to multiply here. We have a negative 2 times a 5. That would give us a negative 10 on the outside, and the inside would be a 6. Okay, so when we're going to, let's see if I can pull this up so you can see it. When we do this, we are going to combine like terms. And if you notice, I have one normal number and 2 square roots of 6. So these are alike. So I'm going to keep my 2. Okay. And then this is a 1 right here. So this would become a negative 11 square root of 6. And then what's left here? Plus 8 times the square root of 3. And that's your final answer. Now, some people would put the 2 first, and then this next, and then this last, because they're ordering the highest as last. I know it's a negative, but the highest radical as last. Okay, so that was 23. Let's see, what else do I have circled? 29. Okay. 29, we have a 6 over square root of 2. On all of these, you cannot keep a radical in the denominator. We want to rationalize it. So in order to rationalize a square root, we multiply it by itself. It pops off the radical and leaves the whole number 2. And then on top, we have 6 times the square root of 2. Now don't forget to reduce. This goes in like this. And so your final answer is 3 times the square root of 2. All right. Okay, next one that I want us to do is 34. 10 times the square root of 5 and 3 times the square root of 2. Now, that's a 5. It looks like a 3 from here, but it is a 5. Now on this, we don't have to multiply this whole thing by 3 times the square root of 2, although if you did that, it wouldn't mess you up as long as you do it on the bottom and the top, and then you would reduce in the end. We just need to get rid of that radical. So we just multiply like this. Okay, so this on bottom, this together, be 2. This is 3 times the 2, which is 6. Then we have 10 on the outside and the square root of 10. And you just want to make sure and look at this. Is there any perfect square inside 10? No, there's not. But we can reduce here. Both of these can be reduced by 2. And so your final answer would be 5 times the square root of 10 over 3. All right. Okay, I have 3 more problems. Okay, number 38. Okay, I keep sniffling. My allergies are a little bit funny this morning. So we have this. Do you remember what this was called? When we have a 1 plus a radical, in order to get rid of it, we need to multiply by its conjugate, which is the same thing, except that middle sign changes. So if it was a plus here, it'll be a minus here, and vice versa. If this was a minus, this would become a plus, and so would this. Make sure that you don't just go, okay, I'm going to multiply it by itself, and then don't do the math, okay? Because remember, the only way that a conjugate really helps you out is if you have opposite signs, because what happens is our FOIL, remember we do FOIL, our O and our I on a conjugate, we don't even have to do. All right, so let's do our first, which is 1. Okay, and then our last, which is going to be the negative, but it's also going to be the 6. Okay, so that's 1 minus 6, which is equal to a negative 5. We're going to remember that for later. Okay, and then on top, we're going to actually distribute. 7 times 1 gives you 7, and 7 times a negative square root of 6 gives you this. So our final answer on this is, let's see, 7 minus 7 times the square root of 6 all over a negative 5. And sometimes in math, they don't like a negative. You know, math people are finicky. They don't like radicals, but they also don't like negatives, so they'd rather have a positive on bottom. So sometimes you'll see things worked out like this. If they change that to a positive, then they just reverse both of these signs. So it now becomes a negative 7 plus 7 square root of 6. Okay, so I would take either one of these. Okay, either or. Okay, all right. Let's see, let's go on to number 48. Okay, one more after 48. So these are solving for the equations, 3x minus 8, and then plus 3 is outside of that radical. The main thing that you need to remember on this is move this first. Okay, you want to isolate the radical. Those of you who watched the videos before, that was the main point. Okay, now, how do we get rid of the radical sign? Good. You square both sides. What do you get when you get 1 squared? 1. Okay, and then this pops off the radical. So 3x minus 8, then plus 8, 3x equals 9. And this, at this point, you're like, oh, thank you, nice book, because everything goes in beautifully, and you get this as your answer. And the only thing that they say to do is plug it back in. So if I plugged it in here, let's see if it's true. 3 times 3, that's 9. 9 minus 8, that's 1. Square root of 1 is 1. 1 plus 3, is it 4? Oops, up here. Yes. So I can check off that this is true. It's not an extraneous root. Okay. All right. Last problem. We'll get another sheet. Last problem in prep for your test is 47. Okay. This one's a little bit different, but it's still something that you have to isolate the radical. And I want you to pay attention to that. Okay, so move that 4 over. We get 6. And is the radical isolated yet? No. Need to get rid of that 2. Okay, so we are here. And then we get, what's 6 divided by 2? 3. Then we square everything. Okay, don't forget to square both sides. So then this would become 3x plus 1 equals 9. And then minus 1, 3x is equal to 8. And then we divide by 3. And then you don't think your book because you're like, oh, this is the ugly fraction. But that's all right. That is the correct answer. So then we just want to check it up here. So I'm going to put it in over here. So 2 times 3 times 8 over 3 plus 1. Okay, I'm going to look at this. Okay, what is 8 plus 1? That's 9. Square root of 9 is 3. 2 times 3 is 6. 6 plus 4 is 10. So winner, winner, chicken dinner. This is not an extraneous root, and it works. All right, so hopefully you have remembered all of this. It took us about 22 minutes, and I'm going to stop the recording. Love you all. Bye.